Okay, our next lesson is on dividing. So we'll start with an example that we've done before. I think we even did this one in class. So one strategy is to try to reduce the fraction that's under the square root. But 11 divided by 49, you can't simplify it. So this is a case where, remember, in the first video I went over the properties. This is where you want to rewrite this as the square root of the numerator over the square root of the denominator. Square root of 11, you can't take the square root of 11, and no perfect squares go into it. Square root of 49 is 7, so your answer is root 11 divided by 7. Okay, now we're going to change things up. 12. Here you are with your variables. So again, 25 and b to the fourth, can't simplify that as a fraction, 25 over b to the fourth. So I'm going to take the square root of each. Square root of 25 over the square root of b to the fourth. Square root of 25 is 5. 4 is even, so I use my trick of 4 divided by 2. My answer on the bottom is b squared. 5 over b squared. Cannot be simplified. That's my answer. 13. Once again, 25p cubed all over q squared. You cannot simplify that fraction. So in the numerator, I'm thinking of that as the square root of 25 times. Now, 3 is odd. So just like before with multiplication, I want to think of that as p squared times p to the first, all over the square root of q squared. Again, a lot of you can do these steps in your head. I'm just showing out what's really going on for those of you who need it. Square root of 25 is 5. Square root of p squared, 2 divided by 2 is 1, so that's just a p here. And then p to the first stays under the radical. All divided by the square root of q squared. 2 divided by 2 is 1, so it's just q. The 5p and the q have nothing in common, so you cannot simplify this. Over here, same deal. I'm going to think of this as root 75 over square root of 16 times square root of t squared. I don't have to rewrite the t squared because 2 is even. So 75, that's 25 times 3. And then I can do the others right now. Square root of 16 is 4. Square root of t squared, 2 is even. 2 divided by 2 is 1. That's just 4t. Now I just have to simplify this. Square root of 25 is 5. I cannot take the square root of 3 all over 4t. The 5, the 4, and the t cannot be simplified. So, if you know whatever focus here, that's your answer. 15. So here's an example where you could simplify before you go ahead and take the square roots, and I'll show you that approach. So first, look at your numbers and just think of it as the fraction 12 divided by 27. So if I have just the fraction 12 divided by 27, what can you divide each of those numbers by? And the answer is 3. So I'm going to do that. So 12 divided by 3 is 4, and 27 divided by 3 is 9. Now again, here we are, properties of exponents. This was maybe 2 units before we left back in March. So if I have a to the third divided by a to the first, do you remember what you do when the bases are the same and you're dividing? Did you say the right answer? You subtract the exponents. 3 minus 1 is 2. That's going to go in the top because it's a positive 2. If you had gotten a to the negative 2, you'd write it in the denominator as a squared. So now I'm just going to take the square root of each term. Again, a lot of you would do this in your head, but I'm just showing it out. Okay. Square root of 4 is 2. Square root of a squared, 2 is even. 2 divided by 2 is 1. And square root of 9 is 3. Last one here, well, actually I have a couple more, but 16. Again, another example where you can simplify. Take the numbers first. What's 27 divided by 3? That's 9. 9 over 1, technically, if you want to write it like that. an x cubed divided by x to the first, you subtract. 3 minus 1 is 2, so it's x squared. This one, the fraction just kind of goes away after you simplify. It's all technically over 1, but anything, you can write anything over 1. So now I just take the square root of each. Square root of 9 is 3. 2 is even. Use our trick. 2 divided by 2 is 1. It's just 3x. And now I have two more that are just a little bit more complicated, I guess, with the dividing. Okay, so notice this one is set up differently. I'm giving it to you as the square root divided by another square root instead of just the square root of a whole fraction. So, do you guys remember how to do these ones? I'm not sure. There are two different ways that people like to do it. I will show the two different approaches that you like to use. Remember, it's called rationalizing the denominator. Rationalize denominator. And so, what that means is, if you forget from when we actually did this, it means you can't have any square roots in the denominator. So, we don't want to have a root 8n in the denominator. So this is one approach. Just right off the bat, multiply top and bottom by that square root in the denominator. Multiply across. Root 7 times root 8n is root 56n in your numerator. Remember, when you multiply a square root times itself, you're just left with what's under the radical. 8n times 8n is really 64, root 64n squared, but the square root of 64 is 8, and the square root of n squared is just n. Or, remember the shortcut that we talked about when we did this unit is just what's under the radical. So now you have to simplify. Mistakes that I usually see, people want to cross out these n's. Remember, we talked about this before when we just had numbers. Also, you can't just divide the 8 into 56 because the 56n is under the square root and the 8n is not. So our goal right now is to simplify the 56 and to find a perfect square that goes into 56. So I think you're going to find out that that's 4 times 14, and then we have an n there. Okay. So square root of 4 is 2. 14 you can't take the square root of, and no perfect squares go into it. And then n has to stay as well. And our denominator is 8n. This is all fine and dandy, but you actually can simplify it. Because remember, this is 2 times the square root of 14n. And these numbers here can always be simplified. You can't touch what's under the square root. So what goes into 2 and 8? 2. So I'm going to divide each of these by 2. So this becomes a 1, and this becomes a 4. So 1 times root 14n is root 14n, and in the denominator you have 4n. Again, you cannot cross out the n's, you cannot simplify the 4 and the 14, excuse me, because those both need to be under the square root, and they are not. So that is your answer. Last one, some people were saying they needed more examples in my lessons, so here's more examples. I tried to do more this time. Now this, I'll do it the other way, where you actually simplify before you multiply. So the 17 I did just straight off the bat, multiply by the radical you want to get rid of. This one I'm going to show where you simplify before you multiply, to remind people of what they like to do. So 18 I'm going to think of as 9 times 2. So I have root 5 divided by square root of 9 is 3. I cannot take the square root of 2, and I cannot take the square root of t. So this would be great, but we can't have square roots in the denominator. So I need to multiply by the square root in the denominator, which is root 2t. You can throw a 3 in here, but that's going to make your life more difficult later. So you only need to multiply by the radical that we don't want. So root 5 times root 2t is root 10t. 3 times technically a 1 is 3. Root 2t times root 2t is root 4t squared, remember, but that's just 2t. So in your numerator, no perfect squares go into 10. You can't take the root of t. In the denominator, 3 times 2 is 6t. And that is your answer. You cannot cross off the t's, because in the denominator, you do not have a square root. And you cannot simplify the 10 and the 6, again, because they're not under, the 6 isn't under the radical.